Section 1.5 Algebraic Division. We'll start with the example. X square plus 5x plus 8 divided by x minus 2. Now, first of all, we want to look at whether this is a proper fraction or improper fraction. When you look at the denominator, we can see degree is going to be 1 and this degree is going to be 2. Degree means highest uh, power of that polynomial. So this x square plus 5x by highest power is 2 and x minus 2 highest power is 1. So this is going to be 2 over 1. This is an improper fraction. Now we are going to learn how to deal with improper fraction. So the first step is the improper fraction we want to write or we want to turn into a mixed fraction. Now we know that 10 divided by 3 is an improper fraction. How do we turn this into a mixed fraction? 10 divided by 3. So this is going to be 3. 3 times 3, 9. 10 minus 9 is 1. So there are 3 fulls and 1 out of 3. So this is the quotient, this is the denominator. The same thing we are going to do with this x square plus 5x plus 8. We divide by x minus 2. Then this is going to be x and this is going to be x square minus 2x. X times x square, this is minus 2x. So you can remember that our technique is to make the this number. So when we subtract those two, this is cancel out. X square plus 5x plus 8 minus x square minus 2x. So x square plus 5x plus 8 minus x square plus 2x. This is cancel out. Likewise, this is cancel out. This will make 5x minus minus 2x, that is 7x. And I'll bring this 8 to down. Now I want to make 7. To make 7x. So this is 7x minus 14. So when I minus this one, this is going to be plus 22. Then when x square plus 5 to x minus 2, the quotient is x plus 7 and the remainder is 22 out of the divisor x minus 2. So we'll discuss another example. Now this is 2x square plus x minus 5 divided by x square plus 3x plus 2. So highest degree is 2. So this one also 2. 2 over 2 is not a proper fraction. So then we want to turn this one into a improper fraction, a mixed fraction. So we have to start the division as usual now. 2x square plus x minus 5 we need to divide by x square plus 3x plus 2. Then when I put 2 here, 2 times x, 2x square plus 6x, 2 times 3, 6x, 2 times 2 plus 4. When you reduce those two, this is going to be minus 5x. This is minus 9. When I subtract those two, yes. Now this is going to be minus 5. Actually, we can't do anymore because this denominator is less than the degree is less than this, the remainder. So that's all we can do. So then the total number is, full number is 2 out of remainder is minus 5x minus 9 out of x square plus 3x plus 2. Now I will rewrite this one like this: 2 minus, I can take um, minus out, so this is going to be 5x plus 9 over x square plus 3x plus 2. Actually this is in uh, already we simplified this one, but this is not. You can see that I can factorize 2 minus 5x plus 9, this one, x plus 2 and x plus 1. Now you can see that with the algebraic division this sum was fully simplified, but now this is not yet, because this bit is pending. Now if you look at this sum only, 5x plus so this is another partial fraction you did in previously, 5x plus 9, x plus 2, x plus 1, and you know how to deal with this one. So this is another partial fraction. When you look at, you can see that denominator, this is a proper fraction. The degree is 2 here, degree is 2x square and degree is 1. So we have to still work on this one. Now I am going to rewrite this one. Now this look like another sum we have, a different sum. So we turn this difficult situation into a much simpler one by algebraic division now. I will delete this part and we'll work out this one, and I will substitute this one. Now you know how to do this one. How do we write this one? A over x plus 2 and b over x plus 1. Now you can write 5x plus 9 equal a times x plus 1 times b times x plus 2. When x equal minus 1, this is minus 5 minus 19 equal, this is 0, plus this is going to be minus 1 plus 2 plus 1, so this is b. So b is going to be 9 minus 24. When x equal sorry, this is plus 9 and this is plus 9, so this is not 19, this is plus 9. So minus 5 plus 9, this is going to be plus 4. And x equal minus 2, so this is minus 10 plus 9 minus 1 equal, this is become 0 and this is become minus a. So a equal 1. Now we can write, now fully factorize now, minus, this is going to be a is 1 over x plus 2 plus b is 4 over x plus 1. Now 2 minus 1 over x plus 2 minus 4 over x plus 1. Now we fully factorize. Yeah, if I summarize again, so in this one we use algebraic division and we fully factorize. In improper fraction, so we use algebraic division and we will bring a mixed fraction. So improper fraction, algebraic division using, we bring into a mixed fraction, and this is job done, it's complete. But here when it's come to this one, it's a mixed number, but we have to solve further because this is a proper fraction, but it's still not solved properly, partially solved, so we have to keep continuing using the previous technique. So this is algebraic division. And now if I divide x square plus 5x plus 8, x square divided by 5x plus 8 divided by x minus 2. Then this is the quotient and this is the remainder. And I can write differently again. X square plus 5x plus 8 over x minus 2. This is qx. I can write this is d over x minus 2. Now I multiply by every side by x minus 2. I want to get rid of this denominator. So x minus 2, x square plus 5x plus 8 over x minus 2, and qx times x minus 2 and d over x minus 2 times x minus 2. So this is cancel out and this is cancel out. Finally we will get something like this: x square plus 5x plus 8 equal x minus 2 times qx, or qx times x minus 2, it doesn't matter. 2 times 3, 3 times 2, x minus 2 function of x plus d. Actually I'll change this one, that is qx times x minus 2 plus d, this one. Now x square plus 5x plus 8 and x minus 2 is here, and I need the x square term here, so I am going to open a bracket and I am going to write so we need to find qx. What is qx? So in terms of constants, in terms of unknown coefficient, so to make x square, so x is here, I need the x, then I put a as a unknown coefficient, then ax plus b, because this is power 1, then the next term has to be x0. X0 is b. Then you can use the equation coefficient technique to work out a, b, d. But I feel this is a bit confuse you, so I will teach the same thing differently now. Now it is clear that we use algebraic division to solve this one method. So other one is equating coefficient. So I will work this sum with that equation coefficient method. Now it is clear that this is an improper fraction. Then we have to deal something with the to make improper. So that's what this is the steps we should follow. First of all, we'll find the difference. So the degree is 1 here and degree is here 2. So what is the difference? 1. So this degree is 2. This is the degree, highest power is 1. The difference is 1. So x to the power 1 is the difference. Then we will write this one x1 and x0 descending power. So this is ax1 plus bx0. Basically we don't write x0. This is a constant. Ax and the constant. Then we dealt with already the which part? The improper part. Then we forget this the numerator and we will look at the denominator and we write c over x minus 2. Now we'll discuss another one. X cubed phi x plus 8 x minus 2. Now first check proper or improper. Yes, this is improper. So now what is the difference now? Second step. This is 3 highest value, this is 1. So difference is 2. Then you're starting from x square, x and the x0 which is constant. Right? So then ax square plus bx plus c is the constant. Now the improper part is dealt already. Then plus. Then look at this one. D over x minus 2. Another example, x cubed by 5x plus 8, x minus 2, x plus 1. Now, first check improper or proper? Improper. Then difference. What is the difference? This is 3, highest power is 3, the highest power is here is 2. So then 3 minus 2 is 1. This is 3, this is 2 because x times x, x square. Then hence this is x1 because difference is 1 and then x0. So this is ax1 plus bx0 which is b. Then we dealt with the numerator part because it's a fraction. Now as usual, when you forget this one, how do you deal with this denominator when it is as a proper fraction? So we write c over x minus 2 and d over x plus 1. We'll discuss one more. This is s cube 5x plus 8. Then this is going to be x plus 2 square. Now when you look at this is a improper fraction. First of all we'll deal with the improper. So this is 3 and this is 2. Difference is 3 minus 2 1. So then I need x. This is the 1. Different 1. And this is ax plus b. x1, x0. 2, 1, 0. Which is 0 is constant. Now I am not worried about numerator. Now I worried about only denominator. So then this one is AB, you can write C over x plus 2. Now you know how to deal with the repeated factor. And D over x plus 2 square. Another example, same one, x 5x plus 8 numerator. I will write x plus 2 square times x plus 1. So how do you write as a partial fraction straight? Now you can look at this is 3 and highest denominator degree is in the denominator is going to be 3 again. Okay. This will make x square term times x, x cube. So 3 over 3, what is the difference? 3 minus 3 is 0. Then x0. x0 means constant. Just you write ax0, x0 is 1. So just constant. And then disregard the numerator, then look at the denominator. Denominator, we know how to do it now. B over x plus 2 and c over x plus 2 square, and there's another linear factor d over x plus 1. Now let's discuss with example 11 in the book. Now first of all look at whether this is a proper or improper. You can see this, the degree is 3 and what is the degree is 1. So what is the difference now? 3 minus 1 is 2. Then you need to start with x square because 2. Then x1 and x0. And then a x square plus bx plus c x0 is 1. So I write, now I dealt with what? Numerator side. So what is the denominator here? Only x minus 3. Then d over x minus 3. If it is x minus 3 square, how do you do? D over x minus 3, then E over x minus 3 square. But the sum is just without that one. Now it is here. Now we need to solve this one. So I don't like denominator, so I'm going to get rid of denominator. So I'll multiply by, I'll write like this. X cube x square minus 7 equal a square bx plus c times x minus 3 plus d. So what I did was, I multiply x minus 3 from all the terms, both sides. That is the usual year 3, year 6 techniques. D over x minus 3 times x minus 3. So this is cancel out and this is come x cube x square minus 7, and this is as it is ax square plus bx plus c x minus 3, and this is d. Now we need to find a b c d. So we need 4 equation. Or I can see that if I put x equals 0, x equal 3, this whole term is going to be 0, and I can find. Let x equal 0. So this is 0 plus 0 minus 7, and this is, sorry, x equal 3, because I want to make this one 0. So this is 3 cube plus 3 square minus 7 equal, whatever it is, I'm not, okay, a3 square plus b3 plus c times 3 minus 3, this is plus d, so this is become 0. So d value is 9, sorry, 27 plus 9 minus 7. So 9 minus 7 is 2, 27 plus 2, 29. So d equal 29. We managed to find now d. Now I can see that if I put x equal 3, this is 0, 0, and a times 0 is 0, b times 0, only c is remaining. And d I know already, then I can find z. So then having this solid, let x equals 0, then 0 plus 0 minus 7 equal, this is 0 plus 0 plus c, this is 0 minus 3 plus d. Plus d is what now? 29. So minus 7 equal minus 3 plus 29. So this is 27 minus 29 equal 20. So this is 36 equal minus 3. So c equal, this is going to be 12. Then if you want, you can find x equal 1 and x equal minus 1, and then take two equations, and then you only know a, b, and two unknowns. Then you will get two equations. Then you have to solve simultaneously because you already know c and d. Or the other technique is to equate in the coefficient to find a and b. So we'll take equating coefficient technique, right? So I will rewrite, this is x cube plus x square minus 7. So this is ax square plus bx plus c times x minus 3 plus d. I'll just simplify to get this one. Okay, I'll write like this. First of all, let's look at a x cube term. So coefficient of x cube is here. So what is the x cube term here? You can see that ax square, when you multiply x, you will get ax cube. So basically, this is x cube equal ax cube. So this is going to be 1 equal a. So a value is 1. Then coefficient of x square. This is 1. You can see 1. And how you can make x square again? Ax square, when you multiply by minus 3 ax square. So that is, you can make, then if you multiply bx with x, then this is going to be bx square. So minus 3a plus b equal 1. So we know already a equal 1. So 1 minus 3 plus b. So b equal 4. Now, if you are confused, I will show how I did. So x cube, x square, you should not do like this. So I'll expand this one with x. So this is ax cube, bx square plus cx. Then this is minus 3ax, and this is very time consuming. Minus 3bx, I'm multiplying by minus 3. Minus 3ax square minus 3bx, then minus 3c plus d. Then x cube plus x square minus 7. There is no x cube term. X square term I can see to this one and this one. So b plus minus 3a x square, and x terms cx, c minus 3b, c minus 3bx, then the constant minus 3c plus d. So you can work this totally with equation coefficient. So when you look at, I will rewrite this one, x cube plus x square, and there is no x term, so I'll write 0x minus 7 equal ax cube plus b minus 3a x square plus c minus 3bx minus 3c plus d. Now when you look at x cube terms, this is 1 equal a. When you look at x square terms, 1 equal b minus 3a. When you look at x terms, this is 0 equal c minus 3b. And when you look at x naught term, which is constant, minus 7 equal minus 3c plus d. So no, 4 unknowns, 4 equations you can solve from here, totally from the equation coefficient. So here what we did was we use both. We take x equal 3 and make it, we found d. Then let x equal 0 and we found c. And then we use the coefficient of equating technique to obtain those two, a and b. So it is up to you. You have to, in the exam, you have to decide which way you are going to use, but this is usually mixture is good. So when you, this is a good working out. I mean, when x equal 3, straight away you can find the d, and x equals 0, then you can see and use coefficient, equating coefficient to find those are the a and b. Let's discuss example 13. Now when you look at, you can see that this is definitely an improper fraction. The degree is 4, here degree is 2. So 4 minus 2 is 2. Then you have to start with x square, because 2, that's why 2. Then ax square plus bx plus c plus, then what is this one? Can I write this as a factor? No. this is irreducible factor. If it is assumed that x plus 1, x plus 3 square, then you can write okay, we can do that. We'll write okay, x plus 3, x plus 2. Then this is going to be a over e over x plus 3 and d e f over x plus 2. Or it is assumed that this is x plus 2 square, then we are writing e over x plus 2 and f over x plus 2 square. Now, but we can't write like this. No, we can't factorize this one. X square plus 2x minus 3. Then we have to write in this form x square plus 2x minus 3. So this is going to be the remainder. Always 1 less than this one we want to start. So dx x square, then 1 less than it is 1. So 1 dx plus e. Now this one you can see this is given in example 13. So when I multiply by this one, I can bring into a one line x square plus x cube plus x minus 10 equal ax square plus bx plus c times this one x square plus 2x minus 3 equal dx plus e. This is cancel out this one because 10 over 3 equal 3 plus 1 over 3. When you multiply by 3, 10 equal 3 times 3 plus 1. The same thing I did. Now you can use any technique. You can take x equals 0, 1, 2, 3, 1, 2, 3, 4, 5 unknowns. You need 5 equations by equating the coefficient, or you can take let x equal 0, x equal 1. Somehow you have to take 5 equation or combination of those two. You can find a b, c, d. Or you can do the algebraic division. So x4 plus x cube uh, x4 plus x cube plus uh, x square is missing, so I will write 0 x square plus x minus 10 divided by x square plus 2x minus 3. So then this is going to be, I want to make x4, so this has to be x square, then x4 plus x square times 2x, 2x cube minus 3x square. So then when you minus this one, this is cancel out, minus x cube plus 3x square, then plus x. I'll bring this one down and I'll bring this one down as well to avoid the confusion. Now I have I want to find minus x cube makes, or minus x square, sorry, minus x. It will make minus x cube minus x times 2x minus 2x square. This is going to be plus 3x. Then I minus those two together. This is cancel out. This is going to be Phi X square. This is going to be minus 2x. And this is come down here minus 10. Then, so far I think I'm right. Then 5 plus 5. Then 5 times 5x square minus plus 10x minus 15. So when you minus this one, this is going to be minus 12x plus 5. Now you can see x square plus x cube plus x minus 10 over x square plus 2x minus 3 equal x square minus x plus 5, then I put this is plus minus 12x plus 5 over uh, x square minus x plus 5. By algebraic division, we found out everything together. So now A is 1, B is minus 1, C is plus 5, D is minus 12, sorry, E is 5. Let's discuss next exercise now.